Newton's third law states that for every action, there is an equal and opposite reaction. This means that forces always occur in pairs. When one object exerts a force on another, the second object exerts a force of equal magnitude, but in the opposite direction on the first object. For example, when you push against a wall, the wall pushes back against you with an equal force. This is why you don't move through the wall. The forces are balanced, and the wall remains stationary while you feel the resistance. In a rocket launch, the engines expel gas downwards, and the rocket is pushed upwards with an equal force. The downward force of the gas is the action, and the upward force on the rocket is the reaction, allowing it to lift off the ground. When a swimmer pushes water backwards with their hands, the water pushes the swimmer forward. The backward force on the water is the action, and the forward force on the swimmer is the reaction, propelling them through the water. In a game of billiards, when the cue ball strikes another ball, the force exerted on the second ball is equal and opposite to the force exerted on the cue ball. This interaction causes the balls to move in opposite directions. The principle of action and reaction is fundamental in understanding how objects interact in our universe. It explains the behavior of objects in motion and at rest, and is crucial in the study of physics and engineering. Newton's third law is evident in everyday life, from walking, where your foot pushes against the ground and the ground pushes back, to driving, where the tires push against the road and the road pushes back, allowing the car to move forward. This law is also important in the design of machines and structures, ensuring that forces are properly balanced to prevent collapse or malfunction. Engineers use this principle to calculate stress and strain in materials. In sports, athletes use Newton's third law to enhance performance, such as in jumping, where the force exerted on the ground results in an equal and opposite force that propels the athlete into the air. Newton's third law is a key concept in understanding the dynamics of forces and motion, providing insight into how objects interact and respond to forces in various scenarios. The law is applicable in both macroscopic and microscopic scales, from the movement of celestial bodies to the interactions of subatomic particles, demonstrating its universal relevance. In aviation, the lift generated by an airplane wing is a result of the air pushing downwards, with the wing pushing upwards with an equal force, allowing the plane to fly. Newton's third law also explains the recoil of firearms, where the bullet is propelled forward and the gun is pushed backward with an equal force, affecting the shooter's stance.